Hello everyone, this is Aditya, and today we're going to solve a mathematics question from JEE Advanced 2025. And I don't know that why is it in so much controversy, because I see a clear one answer in this case. If you all want to solve this problem, then please pause this video and give it a try. Okay, I think that you all must have tried this problem. So according to me, the answer is option number C. I don't know that why there is so much controversy in this problem. So I thought to make a video on this. So please do like, share, subscribe my channel, and please support this video. Now let's start with the video. So this is a question. Let R denote the set of all real numbers. Define the function f such that it goes from R to R by fx is equal to this expression. Then which of the following statements is true? First, function is not differentiable at x. Okay. B, there is a positive real number delta such that function is decreasing on the interval 0 to delta. This is decreasing, function is decreasing. Option number C, for any positive delta belonging to real number, the function is not an increasing function on the interval negative delta to 0. And option D, x is equal to 0 is the point of local minima. Okay, so in this, first of all, we can check for A and D because they are relatively easy with respect to B and C, right? So first of all, let's check for option number A because we know how to check differentiability. It is a very easy process. Okay, so now let's see option number A. Function is not differentiable at x is equal to 0. So let's check it. Let's apply the definition of differentiability that LHD should be equal to RHD, that the left hand derivative must be equal to the right hand derivative to check for differentiability, right? So the given function is this, right? It is equal to minus 2x square minus x square sine 1 upon x if x not equal to 0 and is 2 if x is equal to 0, right? If x is equal to 0, sorry. Right? Okay. So let's apply the formula of LHD and RHD. So LHD, it is equal to limit as h tends towards 0 of the quantity f of x minus h minus f of x upon the quantity negative h, right? Correct. First of all, let's solve for LHD, right? Then we'll solve for RHD. And wait a minute, RHD is equal to limit as h tends to 0 of the quantity f of x plus h minus f of x by h. And of course, we are going to evaluate this whole expression at x is equal to 0, right? Okay. So we have to evaluate it at x is equal to 0 and x is equal to 0, right? Okay. So notice that at x is equal to 0, this expression becomes h tends to 0 of the quantity f of negative h minus f of 0 by negative h, right? So this will become, what is the value of the function f at negative h? Well, of course, it is approaching towards 0 but has not become 0 yet. So it means that the function will take this value, right? So this is equal to limit as h tends to 0 of the quantity 2 minus 2h square minus h square into sine of negative 1 upon h. Since sine of negative theta is equal to negative sine theta, so we can bring negative sign out, so it will become plus 1 upon h minus 2. Since f of x, f at 0 is equal to 2, right? Since we are given that the function value at 0 is equal to 2 divided by negative h, correct? This and this gets cancelled. Now we can solve it. It will be equal to limit as h tends to 0 of the quantity. This negative will become plus, this will become plus, and this will become minus, and this h and this power will get cancelled. So you will be left with h minus h into sine of 1 upon h, correct? Is it the case? Yeah. And this is equal to what? H times 1 minus sine 1 upon h, right? Whatever be its value, it will be a finite value, so it will become 0, right? Correct. So the value of LHD is equal to 0, correct? Now let's solve for RHD, right? Okay. So since we are evaluating it at x is equal to 0, since we have already done it over here, so we can directly substitute over here 0, right? Okay. 0 minus f at 0, correct? Okay. Limit h tends to 0 of the quantity 2 minus 2h square minus h square into sine 1 upon h minus the value of function at 0, again it will be equal to 2, correct? Okay. 1 upon, sorry, minus 2 divided by h, correct? Fine, okay. So from this we can solve it again. So it will become equal to limit h tends to 0 of the quantity, it will become negative 2h minus h sine 1 upon h. And notice that this expression, sorry, here it will be a 2 also, right? Okay. So 2 minus this quantity, but it don't matter much because the answer will still be 0, right? So let's solve it. So we can take h common again. Rather, you can take negative common and then h over here. It will become 2 plus sine 1 by h. And again, since this is a finite value and here we have a 0, so the limit will become equal to 0, right? Which means that LHD is equal to RHD, which means that the function is differentiable at x is equal to 0. So this option is clearly wrong, right? Which means that at h is equal to 0, sorry, at x is equal to 0, the function is differentiable. So this statement becomes wrong, right? Okay. Now let's see for option number D, that x is equal to 0 is the point of local minima. Let's see it. So our fx is equal to this quantity 2 minus 2x square minus x square sine 1 upon x if x is not equal to 0 and is 2 if x equal to 0, sorry, correct? Okay. Now notice that what will be its maximum or minimum value, we have to calculate it, right? So that we can find the point of local minima, right? So 2 minus 2x square minus x square sine 1 upon x, right? So we can take x square common, right? So we get 2 plus, I've taken negative sign also common, 2 plus sine 1 upon x, correct? Right? Okay. Now notice that sine 1 upon x, whatever be its value, it will lie between this quantity, correct? Okay. So when we are adding 2 to it, you will get 1 less than 2 plus sine 1 upon x less than 3, right? This is the value, correct? Okay. Now notice that, okay, now this quantity lies between 1 and 3, right? So this lies between 1, 2, 3, right? Okay. X square minus 2, right? Now notice that what can be its maximum value, right? See it. So 2 minus x square multiplied by something, right? What can be something positive? What can be its maximum value, right? Well, x square is also positive and this is also positive. Now this will be maximum when? When this x will be minimum, right? Now if you substitute x is equal to 0, you will get the maximum value as 2, right? Which means that, but notice that at x is equal to 0, the function is equal to itself, right? So it means that at x is equal to 0, it is the local maxima, not local minima. So it means that this point, this x is equal to 0 is point of local minima, is also wrong. Why? Because notice that it is x square, some positive quantity into a positive quantity will make this expression less than 2, right? It won't go greater than that, right? Since we are dealing in real numbers, right? So it means that at x is equal to 0, we have the point of local minima, right? Of course, don't worry about the domain in this case, since you can't substitute x is equal to 0 in this case, but there's no need to worry because you have x is equal to, at x is equal to 0, you have the answer as 2, right? Fx is equal to 2. So it means that whatever be the graph, it will have the maximum value over here at 2, at 0 comma 2, right? Correct? You can mark like this, right? So this is the maximum value, and what, now we don't know that what will be its graph, but we are for sure that the maximum value is over here. So saying it as a minima is wrong, clearly wrong. So it means that option D is also eliminated. Now we are going to see option number B and C, and let's see it. Of course, if we see here, we are dealing with delta in the positive x direction, and here we are dealing with negative direction, right? So if we solve for one of them, we can solve for both of them, right? So let's start with option number B and let's see it. And of course, I will give two solutions of this problem because one I will give using mathematics and logic, and second I will use some graphs from internet to explain the problem, right? So don't worry about it, okay? Now what does option B state? It states that there is a positive real number delta such that the function is decreasing on the interval 0 to delta. Now what does it mean? Let me explain it. So to understand this, let's take a simple example of a parabola, of a downward facing parabola. This is the vertex at 0 comma 0. This is standard parabola, right? And now see it, suppose, now what does the question state? There is a positive real number delta such that function is increasing on the interval, sorry, decreasing on the interval 0 delta, right? Now suppose it chose a delta such that the function is decreasing. Suppose this is your delta, right, over here. So of course in this domain the function is decreasing, right? Correct. Okay, now let's modify this graph a bit to understand it properly. Now assume the graph goes like this. Okay, correct. So notice that from this point till this point, right, this is your delta. Notice that this graph is decreasing in this domain, but after that it starts to increase, then again decrease, right? Now notice that there still exists a delta which makes this graph decreasing to some extent, and after that whatever happens we don't care about it, right? We just want such kind of delta, right? Now in this problem we have to claim that whether there exists a delta or not, such that the function is decreasing in the interval 0 delta, right, where delta is some arbitrary positive value, right? We can choose it, right? So we have to find such delta. Okay, so let's see it, right? Now notice one thing, that the interval is from 0 to delta, which means that 0 is not included in that, so we won't worry about this one and we will worry about this one only. Okay, so fx is basically equal to sine 1 upon x, right? Okay, so fx is equal to this expression. Now let's differentiate it, right? Yeah, let's differentiate it. So f dash x is equal to basically what? Is equal to negative 4x minus 2x into sine 1 by x minus x square into cos 1 by x. Now let's apply the chain rule, negative 1 upon x square. So you get f dash x is equal to negative 4x minus 2x sine 1 upon x plus cos 1 upon x, right? Okay. Now what is the condition to be increasing or decreasing, right? You know that f dash x should be greater than 0, right? Greater than or equal to, right? Or f dash x must be less than or equal to 0 for decreasing, correct? And this is for increasing, right? Okay, makes sense, right? We are checking for the slope actually, right? Correct. Okay, now notice one thing, that if we go for very large value of delta, then this function will of course be not just decreasing, it will both increasing and decreasing, right? It will be an oscillatory function since we see sine and cos, right? So we can claim that this delta will be very small, right? It will be very small, right? Maybe it tends towards 0, right? It is very small value, suppose 0.0001 or suppose smaller than that, right? So in that case, notice one thing, that suppose if delta is tending towards 0, means it is going towards very small value, suppose 0.000001, something like that. Okay, then in that case x will tend towards 0, right? Okay, so we can approximate that f dash x is approximately equal to cos 1 upon x in that case, correct? Now notice that cos x itself is an oscillatory function, right? Okay, so which means that this function will oscillate from negative 1 to 1, right, all the time. So if I chose suppose domain from 0 to 0.001, right, correct, then in that case also it will have infinite oscillations, right? Because this will itself consist of infinite oscillations of 0.0001, 0.00001, right? Correct. Which means that it will consist of multiple infinite smaller oscillations, right? Which means that this function, we cannot ever find such kind of delta which will make this expression always negative, right? For smaller values of x also, because there are infinite oscillations between a single oscillation in this case. Understood or not? So that is option number B also fails over here. So in that case, option C is only correct, right? And it is indeed true also that it is not decreasing, it is not an increasing function on the interval negative delta to 0, and it is correct, right? Did you understood that what I said over here? Let me explain it. So suppose the graph starts from 2, right? Now for very small value of x, it will go something like this, right? And after that it will keep on increasing, right? Now notice in this interval, in this very small interval also, you will see infinite smaller oscillations in that case, right? Since you can see if you substitute this over here, 1 upon 0.0001, you get 1000 in that case. And for this you'll get 10,000 and something like that, okay? Which means that at very small intervals also, you will find infinite smaller oscillations, right? At very, very small values of delta also, be it really, really close to 0. In that case also you will find infinite oscillations. Now it means that there is no positive real number delta such that the function is decreasing on the interval 0 to delta, right? Understood it? Okay. This is the basic graph, and yeah, I will try to explain it using the graph from a website also. It's called Wolfram Alpha. So from that, I will try to explain the graph in a better way so you can understand this problem in a better way, right? So I hope that you enjoyed this video. If you did enjoy this video, then please do like, share, subscribe my channel, and please support this video. And I think that after this, there should be no controversy on this question because I can clearly see only C option is correct in this case. So if you all enjoyed this video, then please do like, share, subscribe my channel. Bye bye. Take care.